This is a quick video to introduce methods. There's a little bit to talk about here because C# has some unique things that we need to talk about. But this is just to kind of set up just a review of what methods are. So first, methods are functions that are members of a class. So methods is kind of a special object-oriented paradigm way of referring to functions or procedures. So a procedure is a named bit of code that you can call and invoke, start executing by calling it by name that you've saved. So think of it, how would you think of it? It's just a body of code that can be called at any point whenever you need it. Which is known as a method call. So again, methods and functions, procedures, subroutines, these all kind of blur together. There's subtle distinctions between them, but a method is a function that's a member of a class. And every now and then I'll slip and say function because I learned C, which is not object oriented. We just had functions. So okay, so I've added a couple here just to show. First of all, we've been using methods the whole time because every event handler is, so you double click and it creates one for you. That's a method. So just talk about the anatomy a little bit. You've got the name of the method first. That's how you call it, plus the argument list. So these are parameters. Argument and parameter are two terms that get used interchangeably a lot, which is fine. Technically, there's a difference when they appear here in the list of the definition of the method, which this is what this is. This is a method definition, this entire thing. That's how the method is defined. In the method header, this list of variables inside the parentheses after the method name, these are called parameters. So these symbolize the kind of thing you can send as an argument to this method. So this is a built-in thing. What happens when this when this method's called, the btn clear click, when this method is called, the object that called it is sending an address to itself as sender, and then there's these event args that depend on the object that's sending it, or actually what the event is. There's different arguments, so there's a collection of those that are sent as well. So, and actually notice it's called event args because that's what's sent to this parameter. So on a test, make sure you know the difference. Parameters are what's in the method header. Arguments are what you send to the thing when you call it. So do I have an example? I do. Okay, so here's one that's built-in stuff. Let's look at one I made. So I had a bunch of logic in here for playing a game of craps. I think it's correct anyway. What I've done instead is taken all of that logic and made it into a method. So I can call it whatever I want to play craps. Notice, I don't think I mentioned this, but I made a region for all the stuff with the if-else version. I've just kept a switch for now, but I made a region to collapse in case I ever want to go back to it. Anyway, it's a tangent. So this is the method definition. It's from here, and I won't be specific about this because people get confused about these terms. So this is the method definition. Everything that's highlighted. And you can notice it'll line up, the curly brace will line up correctly. Actually, this is the whole definition right here. It gets confusing. Everything that's collapsed is the method body is collapsed in here. So it goes all the way through where the text boxes get their values. So I want to focus on the method header. First, you have an access specifier. I'm using private on this one. Typically, you want to use private unless you have some reason not to. The reason you use private here is because no other form needs to play craps. So the playing craps only takes place inside of FRM demo. So make it private by default. This is public because if you ever need to create another form demo instance, you have to have a public constructor in order to do that. So by default, most of the time, your constructors will be public, but not always. You have sometimes like inner classes and such when you would have a private constructor, but that's an advanced topic we won't talk about for now. This is a public class, so you can actually like instantiate it and run it inside your program. These dice I didn't actually specify, but by default, if you don't specify, they will have private scope. I usually like to make sure I always put it, but I didn't for whatever reason in this example. So these dice are private fields. So that's enough about access specifiers, I think. Just when in doubt, inside of a form, make it private. The only time you're going to make it not private is if you've got a bunch of forms going at the same time and one's calling a method that's inside of another one. That's the way to think of it in a .NET Windows Forms environment type of thing. I'm not saying that's the only time. I'm just saying that's the typical case where you would make it public. Like maybe you have a form that does a calculation for some kind of financial thing, and a bunch of different forms need that calculation, then you would make it public. Okay, so next, so the return value is void because it doesn't return anything. It doesn't return a value, so it just returns without anything. So that's void. That's the same as Java and C++. Then you got the name of the method, just like Java and C++. I'll call this one playcrafts. Notice it's a capital P. I don't know why it automatically generates lowercase, camel case for methods on event handlers. That's fine, but I've learned Pascal case is what we're supposed to use for method names, so that's what I'm using. You can see I do it up here too. And then the parameter list. So mine takes one parameter that's an integer. I call it number of games. This is a local variable, by the way, just like, let me see if I hope I have one. Yeah. Number of wins and number of losses are also local variables. These are all the same kind of thing, the parameter and these two local variables, and this one too. The only difference is that this can have arguments sent to it from outside of the method. These are the values they get are all entirely inside the method, but they're all local variables, which means they're created on the stack. All right. If you don't understand that last part, we'll probably go over it in the future. So the body of the method is everything between the curly braces. So between that curly brace and the one that lines up with it, that's the body of the method. The whole thing taken together is the definition of the method. So what this one does, the way, well, actually to go along with one other piece of terminology, this is a method call right here. This, by the way, is unneeded. It can be helpful though when you got IntelliSense, because if you just start playing, I think it might know what you're, yeah, it does. It detects what you're talking about here. If you just start typing play craps, you can sort of get to it quicker if you do this though. This dot, and you can see play craps is here. So either way, it doesn't matter. You're just saying I'm calling the play craps method of myself. Either way, and again, it's sort of redundant. You don't really need the this, but it's not wrong to put it there. So first I get the number of games, and then I pass the number of games as an argument to that method. So again, all I've done here is I've taken out all the logic from the event handler and put it in a different place for playing the stuff specific to playing craps. You would want to do what I just did in this case. Why not just leave it there, you might ask. Well, one thing you might do is like, I want to give a name section of code that has a specific purpose so I can go and refine it. You can see I've already refined mine. I did a switch, I did if else's, I made changes there. You keep all the changes localized to the task. And the other reason why it might be that you have more than one task you do with the event handler. So first we play craps, and then we do some other thing, and then another thing. So you can just make all the method calls that happen when you click that button inside the event handler, and then reserve all the logic for the different things that you do with you know, first you play craps and then you do some totals or something and do some statistics after that, whatever. you localize that logic to the method. So the point of methods is that they have a single well-defined task that they do. Now, how many lines it takes to do that defined task? In this case, my defined task is to play craps. And I can also squeeze in presenting the results, for example. You could have separated that subtask out, and I didn't, but you could have. So that's the way you want to think of methods, is they have a well-defined task that you can call whenever you need to do it. All right. Yeah, number of games. And like, you could just have it where it plays one game and then you could redesign this different ways, but that's fine. So this was meant to be like a way to show you all the basic anatomy of a method before we get into the stranger C# stuff. I just want to go over this clear controls really quickly. You might have seen something like this before when I was talking about downcasting. You'll see some examples in the book where they do each text box, for instance, one at a time. So if you look at my form, I have 1, 2, 3, 4 text boxes. In the book, the example will be text box 1.text gets 2 double quotes, so empty string. Text box 2.text get. You do one at a time. Using downcasting, you can, this is especially useful. In this case, you're not really saving a lot of lines, but let's say you have 100 text boxes. You might want to do something like this. So you have a clear controls or reset controls method. I call this clear controls because they're all text boxes, but maybe you have some check boxes and radio buttons and other things that you can reset. The way to do that is to iterate over the controls collection. So every form has a controls collection that contains every control that's on it. And what I'm doing here, this is another kind of loop too. I'm iterating over all the controls, and I'm detecting if the control, this is keyword, it checks to see what type the thing is. So if the control I'm currently looking at is a text box as opposed to a button or whatever, then I do some specialized code for text boxes. I downcast the control in question that is a text box to a text box variable, and then I set the text property to double quotes or empty string. The last thing I do, actually, is this inside the for each. I should do this here. It doesn't hurt anything, but kind of does it too many times. The last thing I do is give focus to the first text box, so I don't have to move the cursor there to start typing. So just to see this in action. But the reason I'm showing this to the main thing is that it's another method, right? It doesn't have parameters, so that you don't send arguments to it, because all the information you need is in that controls collection, basically. You don't have to know about any specific control. All that can be handled inside the body. So this has no arguments. It has no parameters. No arguments are sent to it, so that means it doesn't need parameters. And it doesn't return any value. And it's also private to this form. You're resetting the controls of this form. No other form needs to know anything about that. So you make it private. So when you run this, just to show an example, we're going to do 1,000 games again. Roll, it does all this stuff, and then I will clear out the text boxes. That's what this method right here is doing. When I click on the clear button, it executes that btn clear click, which the whole body of that is just to call clear controls. So that's a little bit of an intro to methods, and we'll do some more specific tweaks on this for C# in further videos.